Hello guys, am I live? Okay, let me check once. Yes, I am live. That's cool. Okay, so what are we going to do today? We are going to fix our previous mistake. Yeah. So some days before in my first live stream, I made an encoder app. So that was not really working. Actually, it was working perfectly. I didn't make any errors. But the algorithm that I made was literally so trash. I will show you right now. So this was the encoder I made. Where did it go? 1.py. No, no, no. Where did it go? Yeah, this one is the thing, right? So let me show you guys. So the decoder was all successfully decoding this thing, but see Parthiv. Oh no, this was not the main 2 was the thing. No, no, it was the yeah. So main2.py was the real deal. So here, if I do Parthiv here, you see is the giving this thing. So if I change the key to, for example, 6, the thing should change, right? But again, if I give Parthiv here is giving the same thing. So I was wondering about this, and I realized that I'm adding the key here, and I'm then subtracting the key here again. So what the hell? So but if I do not do this, right, it will obviously say out of range, because I'm going to show you, because Parthiv, see, I is something like, wait, let me say, I is like, where did it, yeah, so 22, 29, so 29 is obviously out of range, right? And yeah, so that will not work. So the thing that we have to do today, we will so I have planned out some methods that we can solve this. So method A that I have, you know, figured out is that we can just make the list bigger. So for example, if we, one second, let me, one, okay, the focus assist is on. So the letter, it has 0 to 25, right? So if I increase it to, for example, 999 repetitively, so it will obviously work. So that's the first method. Method B, divide the key, right? It's the key, sorry, divide the this thing I, divide the I here, divide the I here, divide it, right, and get the remainder I by 26, I think, because then 0 to 25 everything will be covered, and then get the remainder. So we can do that. Method C is use a for loop. So I have not really planned the structure of this one here, and I don't even think that will be a good option. So what I'm going to do here is just ignore method C. um, you can do that for me, and I the making the list bigger, it will also be really easy, and I want a challenge. So what I will do is I will implement this thing. By the way, if you wonder how will I get the remainder, it will be really simple. I will just do this thing, modulus, I think it's called. So yeah, let's do that, and let's see if it will work or not. Index equals to pass. Oh, sorry, this doesn't work. Let's just make it 0 for now, and make this index. Now what will be this one? I percent I percent key. Sorry, I percent 26. Right. So now this should work directly. This should work. If this works just now, it will be okay. So we add suo is the thing. We add suo. By the way, don't forget, guys. Even if we are successful, we'll also have to code this also. So key equals to, now let's try 87, right? So now if we do this part tab, yeah, so it's changing now, you see. So I think we have already done this. So, in how we have figured this out in 5 minutes. So now if we don't face any problems during making this, the decoder, this will be very short, right? So letters dot index, now this will be a little bit harder, but because we will have to actually analyze this. So the key, let us make this the same, 87, 87. And now word a plus equals to I, so this is really nothing, right? Yeah. Now letters dot index I. Now this is a thing. Hmm. So for I and word b, I plus equals to key. So here we will have to change some stuff, right? Okay. The decoder will be a little hard, as you can see, right? Okay. So this is the number array. Basically, this is the number array. So let's not do anything here, but let us print it here. Print word a. And now I will see this parthiv. Oh, sorry, my bad. We will have to print word b. Huh? Yeah, word b. So word b is here, and now we will have to see what the course codos correspondence. You know what, forget. So we will just print word. I think it's word. So if I run this now, right? Let's run this. Part. Oh no. Okay. So let's run this. Paste this. 15, 0, 17, 19, 7, 8, 1. So now if we print word print word C, maybe. No, word C. Why it will be word C? Word B. Let's try word B. Yeah, 103.89. Word C. Maybe let's try word C. Oh no, word C is that one only, right? So what the hell is wrong with this? Oh, I understand, right? Because index, if we make the array of the index, this will be that, right? I am pretty sure. Print. Let's print the indexes. Indices. The plural is indices. I know that one. Index. So now let's run this. 2511. So this one starts from 15. That's weird. Okay, that's weird. So what does it correspondence to? Okay, then I guess it's just word A, right? Because if it's not the index also, it's just word B. Huh? B? No, not word B. It will be word A. Yeah, it will be word A. I think so. It will be the word A. Partib. Yeah, no, 16. Why is it 16? Word dot append n plus 1. Why are we adding? Oh, yeah, obviously we will add 1 because it starts from 0 there. But maybe we are not. Oh, there is a 0 there, right? So we are starting from 0 there. But wait, do we even need this? Okay, let us give it a word which has a Z. Z, zebra maybe, zebra. IOMD. IOMD, right, that's very good. Okay. Um, So it starts from 0, that's not a problem, right? So now, if we again run this, and now if we tell it to decode partib, we get that array. Yeah, we get that array. So word B is the word A of this one. So let me comment all of these because I don't really need it now. Okay. Print word B. Right. So we are printing word B here. So print word B. Okay, so word B here it has the same thing as word A here. Yeah, if I'm not mistaken, that's that. So print word A. Okay, so let us just use our word C, right? For I in word B, right? Let's subtract. We will have to do the opposite of this, right? So I plus equals to plus minus. Okay, okay, okay. Let me try this. I minus equals to, right? I minus equals to key plus, we will subtract it all together, right? So we it's plusing here, we will minus there. So word B dot index, what? Hi, bro, what the hell am I doing? Word B dot index. So word B dot index I. Okay, understood. So here I is what? Sorry. So what is it doing here? Let me analyze this. Huh. Word C dot append I. So I can do that here. Bro, am I dumb? Why am I giving parthiv here? Okay, okay. Okay, word C. Let's give print word C here. And let's run this. Give parthiv, give parthiv here. Copy this. Right. Paste, open this. Give it here. Huh? Why is it coming in negative, man? Okay, this will be a rough day, man. Oh, we are going reverse, right? So, this will not be this one. Okay. We will have to do this, right? Because um if I run this, right, for example, leave this one. Let's just, okay, here let's just pass here. Pass, pass here. Print word B here. Right. We are just getting the base thing here. YKC. So we are getting this 2410, whatever that is. So Enter the word that will be encoded. Enter the word that will be encoded. So we were using parthiv here. Okay. Oh no, why did I print this? We don't need to print this here. In here, we don't need to print this. Print word A, no. Print word B. Bro. Now, huh? And oh, this will be word C obviously. So, parthiv again. Huh? Oh, I am just entering the letters. Oh, oh no, yeah. So here we will actually print the indexes, right? Print index in the indices, right? So here if we enter parthiv again, 24, and if we run that decoder 24. Okay, so the list of indexes is the same as word B. So how do we get I from that? That's a very good question. So index. Okay, let's visualize this with the best software in our world, Paint. So for example, if we divide something, right, in this case we are dividing um, index equals to I divided by 26. So we are dividing 26 by I, right? And after getting x quotient here, we are getting remainder what? Index, right? So what does that imply? That implies that if we multiply x and 26, we will get I plus index. Okay guys, 1 second, I am hearing knocking sound on my door. By the way, I have accidentally erased that one, my paint one, so I will use this. Bye. 1 second guys. guys, I am back. So guys, I forgot to say, um, happy Roth Jatra in Bengali. It's a good festival for Jagannath God, you can say. So I remembered that after eating the jalebis. So yeah, sorry to be late, but yeah, happy Roth Jatra. So as I was saying, yeah, I was coming here. So if we multiply this, right, we will get, for example, let me take an example, 2 5. In remember here, we get this. So if we multiply 2 and 2, we get 4, and it's 5 minus 1. Sorry, minus multiply. So in theory, if we multiply 26 into x and divide I minus index, this should match, right? So we will do exactly that. 26 into, what's the x again? Let me check. 26 into, this is the place. Okay. No, the thing is that we don't have a x here. Hmm. Interesting. See, we don't know the index. We know only, we don't know the x. We know 26 and we know I. So what should we do now? Wait a second. So 5% 2 will give 1. Right. 5% 2 will give 1. But 1 into 2. Okay, so how do we get x here? Hmm. So does proven maths does need coding, and sorry, coding does need maths. So let's start, right, and we will see if the idea follows. I, oh, 1 second. So 26i equals to, we know, sorry, sorry, we know 26x equals to, you know what, let me just use text, man. Text. So 26x equals to, um, we know that equals to I minus index, right? So what will be index? Index equals to I minus 26x. So index equals to I minus 26 into, now what will be this? What will be our x? Hmm. Oh, this is a problem that I need to think about. You know what? Let's just do trial and error, right? I percent 26. What will this give out? Here, if we see here in this diagram, right? Our example diagram. Why did it become so light? Ayo. Oh, this one I was using. Nah, yeah. So if we see here, um, eh, what are we doing here? Here we are doing I divided by 26 remainder. So here, if we do 5, which is our I, divided by 26, which is our 2, what will be the thing? The remainder will be 1, which is the index. So wait, will this work? One second. Word C dot append index. So now this should be corresponding to, oh, I said it correctly, corresponding, whatever. So this should be the same because words is the word, right? So word B, this should be the same as word B. Oh, why am I doing this again and again? Okay, so let me just first encode it. 100 to what? Word A actually, sorry. Wait a sec. Man, this is confusing as hell, honestly. Parthiv. So it gives 15 0. Okay, we will just remember the first two. So 15 0, and this gives 2410. Why? Wait, I have heard that number before. If you go a bit up, 2410. So these are the indexes, right? These are the indexes. Wait, I just realized something. We are not using any keys here. Or are we? Or am I just blind? Huh. Here, where are we using the key? I. Oh. Man, this is confusing. What did we print in this time? Obviously the indexes. Now wait a second. So for let's just start. For I in word C, according to my heuristics, as people say. Wait, I don't like seeing the red line. So according to my heuristics, if I index, now we can, I think, do this code where it is, yeah, this one. I minus equals to key plus word. Okay, key word dash dot index. Which index? Yeah, yeah. Word C dot index, I guess. Index I. So now if we print this, you know what? Let's just for I in word. Oh, we will have to now app word D dot append, right? Index. Huh? I, sorry, sorry. I, right. I. Now in word D, right? Now what will happen is very simple. We will just print word. We will just, we should just word f dot append letters dot index I. I. Will this work? Now I can delete every. Sorry. Okay. By the way, I am holding shift plus control plus right arrow. Shift is for selecting, control is for uh, skip skipping letter word by word. Yeah. So let me just do this. What happened? Minus 63. Where the hell are you getting minus 63? Key equals to 80. Wait, do we need to do this first and then this? It's looking very likely. Hmm. So, hello, hello, hello. Okay. So, this encoding part is really hard. The this will be word B. Okay. Let's try this now. And let's use that one here. 15. What do you mean variable 15 is not in the list? Of course it's in the list. Oh, sorry. Sorry. This will be not this, right? 15. Sorry, I. Right, this should work. God, oh God. It has finally worked after so many times. So for I in word F, we will create the word 1 here. Word 1 plus equals to I. Print decoded word equals to. Okay, now I was watching that they what noob programmers how do they code, and that guy said there that apparently noob coders don't use F strings. So from now on I will use F strings. So yeah. Okay, decoded word partial, and I don't want to print anything. Um, yeah, not this one. So now let me just do some finishing touches, and I will read the decoder that thing again, and then we will be done. Okay, so here let me analyze. Okay, so word 1 plus I. Then na 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 na. Okay, let me mute my phone, guys, once again. Yeah. So word C dot append I. Okay, so let's analyze this. So word A is just a strings, just an array of strings of the word. Word A dot append is just the strings are converted to letters. Sorry, numbers. So then we are just doing this. We are just subtracting it. Um, right. Actually, I wanna see print. Let's. I just wanna see word C 1 second. Are those that 2410 those things? No, these are in negative. Okay, negative words also work, right? Because the remainder will be the same. So okay, remainder will obviously be always positive, right? Remainders are always positive, right? Right? Yeah, they are. Let me search this up in Google. 1 second. I don't trust myself, guys, and I am very careful while spreading information on internet. Remainders are always positive, meaning it can be zero or a okay. He said no, but then it told it's non-negative, not positive. But I was thinking, what the hell? Those are the same. Then I realized it's talking about zeros. So yeah, they are only positive, you can say, in this case. So yeah, you get my point. So for I in word D, word F dot append, there's I. So that works. That works really well. Is this thing working? Yeah, it's okay. So I understand it. How did I do? Now we can go here 69. Right, 69.py, and then no, I think it was 2.py. Yes, 2.py. That was another thing. So if we go here, right? Wait, one thing. Main 2.py. This is the encoder. Yeah. So here it can obviously do this, right? A J. Okay, we what am I? A B now. Let's see B. B will be K J K. Oh, it's like that. But still, the key is important, right? So this can be still coded because I'm not a freaking expert. But yeah, then this will be actually very easy to decode. But okay, let's firstly let's make the decoder using this. A J B K C A B C D F G H I J K L M N K L L L D will be M. Okay. So can I add more values? I don't really know that. But let's try. It doesn't hurt much to get an error. Let's give it till much only. Okay. So now Python debugger. Okay. How many epochs did I give it? Epoch. Okay, the epoch is like this. Okay. So I will change the epoch later. Don't worry, guys. Okay, so previously it wouldn't let me give input, but I have obviously modified the thing, so now we can give input. So yeah, yeah. Here it was already data given I think, judging based on the comments. So yeah, now we can give this. So let's give it like P. P is Y, and as I remember, this is also Y. So H, huh? Uh, what am I doing with my life here? So for every key, obviously, yeah, why? So for every key, we will obviously have to change the training data set here. By the way, yeah. If you are wondering why did I just start doing this, I promised you guys that I would do this later on in the last stream. So yeah, yeah. Now, if you guys are wondering, what, how we are we going to um in decode whole words. So for I in, we are just encoding it the same way, so we are not really decoding it, but using this we can actually make the decoder well. So yeah, so for I in, um let's just get the word first, right? Word word 1 equals to let's I will not take input again. I will just, let's say, parthiv again. Right, parthiv. I in word 1. I will do hashtag this one. So for the I in word 1, this will not be input, this will be I. Right. So, and then um, predicted char. Let's create a word 2 here also. Word 2 equals to empty string, and word 2 will be word 2 plus equals to predicted char. And now print predicted char. Sorry, word 2. Now this should work. Okay. What? So obviously there will be errors, guys. Nothing works on the first try. So is this a bit similar, at least parthiv? Why? No, it's not. Okay, we can just increase the epoch, right? That always works. For I in range, EPN, epoch number, by the way, if you are guys wondering, EPN equals to 1 E plus. I am learning to use this, guys. Okay, 1 E plus this thing, 100. So that's, I think, 10 to the power 100, not that much. So this will take some time, I am pretty sure. Huh? What? Oh yeah, we will have to do this here. Int. Okay, now let's do this. No, no, it will take too much time, I guess. 10. Okay, it will not take that much time, I mean. Loss has already become 0 at what mark? At the near marks only, like around 1800. So for next time, let's just do this 2000, right? For the next time. I will not save it right yet. What the hell? Why is it going on still? You know what? Let's just restart this at around this mark. Yeah, Why is QRK? Did it even get the second word right? No, it didn't. Okay. See, it's definitely not the error of this the program. Program. Oh wait, obviously this will not work because you see we are adding another thing after the key. Okay. So at least the neural network can't crack our encoding. So guys, that's it for today. I mean, it obviously can. It obviously can, but a simple one can't, like this one. So guys, that's it for today. Thank you for your time if someone's giving the time. And but whatever. For now, bye bye.